Hello everyone, Ramya, Assistant Professor of Computer Science Department from Rohini College of Engineering and Technology, subject code OMD 551, Unit 3, topic Power Line Interference, Right Leg Driven ECG Amplifier. Objective to learn about the concepts of power line interference and right leg driven ECG amplifier. Power line interference. Here the power line interference of 50160 Hz is the source of interference and it corrupts the recordings of ECG. It is used to extremely important for the diagnosis of patients. Therefore, it is caused by electromagnetic interference power line, and also it is used by the machinery which is placed nearby. Then the signal component holds harmonics with different amplitude and frequency. The harmonic frequency is integral multiple of fundamental frequencies such as 50 Hz, and the stray effect of the alternating current fields due to loops in the cable and the improper grounding of ECG machine or the patient. Then it shows the circuit diagram of HCZ power line interference. Here the noise from electric power is a major source of noise during the recording or monitoring ECG. Then the different noises have different frequencies. The noise with low frequencies being problem with ECG signal, as well as sometimes high frequency noises also interference with ECG like mobile phones. And then the 50 Hz alternative current is reduced in voltage, rectified and then filtered to obtain low voltage direct current, and it is used to give power to those electronic devices. Next we are going to see the right leg driven ECG amplifier. Here it is a circuit, is an electric circuit that is often added to biological signal amplifiers to reduce common mode interference. Biological signal amplifiers such as ECG, EEG or EMG circuit measures its very small electrical signals that emitted by the body, and then it also contains the patient's body can also act as an antenna which picks up electromagnetic interference, especially 50 by 60 Hz noise from electrical power lines. And also we have the other methods of noise control include Faraday cage, twisting wires, high gain instrumentation amplifier, filtering. Then we are going to see the improvement of CMRR using right leg driven. That means the isolation of the patient preamplifier can also be obtained using an optical isolator. It is used to minimize the common mode signal between the body of the patient and the floating current. So it is used for the common mode signals after amplification in a preamplifier. Then it is inverted and feedback to the right leg electrode. It is reducing the common mode voltage of the input with respect to the floating current. Here the Winter and Webster examined optical design parameters for a driven right leg circuit. And then the presence of stray capacitance at the input of the preamplifier causes common mode currents to flow in LA and RA, resulting in a voltage drop at the electrode resistors. In other words, the potentials at A, B and C are equalized through an in-phase component of the common mode voltage, which the amplifier delivers through C1 and C2 are kept equal. Here the independent of the imbalance in the electrode resistors and stray capacitance. Here the modern ECG machines with their completely shielded patient cable and lead wires. It also high common mode rejections are sufficiently resistant to mains interference. Here also it could be locations where each interference cannot be eliminated by reapplying the electrodes or moving the cable. Here also we have the attenuation provided could be up to 40 dB. In this way the trace is cleaned up by the substantial reduction of line frequency interference. Thank you.